Hello, in this video we're going to be talking about how we graph the tangent function. So here I have the parent function y equals tan x. This is the graph of it. Let's list out some characteristics. Alright, so what you're probably first noticing is that tan just keeps repeating itself over and over and over. Just like sine and cosine, it is periodic, which means that it repeats itself. But then we have these vertical asymptotes in between, so the graph keeps getting interrupted, right? So its domain is actually being interrupted. And if you're wondering where these vertical asymptotes come from, well, remember that tan is just sine over cosine. So like here at pi over 2, you can see pi over 2 right here, sine over cosine would be 1 over 0, which is undefined, which gives me these vertical asymptotes. And this happens every pi times around the circle. So pi over 2 plus pi is 3 pi over 2, right? So every single pi interval, we're going to have a vertical asymptote. This tells me the period of tan. Tangent, the parent function tangent, has a period of pi. And remember, this is different from sine and cosine, which have a period of 2 pi. So the next thing that we're going to look at is the vertical asymptotes. So how do we measure where these happen? Well, for tangent, the very first one is at pi over 2. So I say it's at pi over 2 plus, it happens every time I add or subtract pi. So I'm going to say plus pi in. And now I can use the same type of thinking to find all of the x-intercepts, because the first x-intercept is here at 0, and then every period you're going to get another x-intercept. So plus pi, plus pi, plus pi. So the x-intercepts occur at pi in. Remember that in is just, however many times you want to add or subtract. And then the last thing that I want you to notice are these points here and here. Why do we get a y value of 1 right here? What's this value? Well, in between 0 and pi over 2 is pi over 4. So look at pi over 4 on the unit circle. What's root 2 over 2 divided by root 2 over 2? 1. Or if I were to go negative pi over 4, so this direction, negative root 2 over 2 over root 2 over 2 would give me negative 1. And so these are just a couple of key points, and they always occur right in between your x-intercept and this asymptote. And I'll tell you how to find whether or not it's 1, or maybe we've stretched the graph vertically. Right? Let's look at what happens if we stretch it vertically or compress it, and same horizontally. So now let's look at transformations. Y equals a tan bx. A is going to give you your vertical stretch or compression, and it's actually very easy to deal with. B is the horizontal stretch or compression. And B is important because it affects the period. Affecting the period means it affects the vertical asymptotes and those x-intercepts. And we find the period of these functions by pi over b. And you need to notice again that this is different from sine and cosine, which would be 2 pi over b. Alright, so before we get into graphing, let's just talk about x-intercepts and vertical asymptotes. How we could find them just given an equation. So remember from earlier in the video, when y equals tan x, we have the vertical asymptotes here. So what about whenever y equals tangent of bx? Well, if you just remember that the vertical asymptotes, these are just equal to x, and the x-intercepts, these are just x values. To find my x-intercepts and vertical asymptotes, I'm just going to set these equal to bx. All right, and now from that, let's go ahead and try to do an example. Let's do y equals tangent of 3x. Well, the vertical asymptotes would occur, I'd say 3x equal to pi over 2 plus pi in. Solve this for x by dividing each side by 3. So this will have vertical asymptotes at x equals pi over 6 plus pi over 3x. I can do the same for the x-intercepts. I can set 3x equal to pi in. So this will have x-intercepts at x equals pi over 3 in. Alright, so let's graph y equals 3 tan 2x. We'll start by just labeling out some stuff. A is 3, and that's going to let us know 3 and negative 3. We'll have some key points there. The period is going to be pi over b, so that would just be pi over 2. So the distance between this asymptote over here and this asymptote over here, this distance needs to be pi over 2. So what's the distance between here and here? That would be pi over 4. It's just half of the period in each direction. And since this is right in between those two, this must be pi over 8 and negative pi over 8. Another way that we could have found all these points is just looking at the key point increments, where you just take the period and divide it by 4, and pi over 2 over 4 are increments of pi over 8. So really you can think about it either way, either as the increments or just cut your period in half and then cut that in half. All right, because it's a positive tan, it is an increasing function, so it's going to hit this origin. It'll hit pi over 8 positive 3 and negative pi over 8 negative 3. If I wanted to do another period, I would simply just keep adding pi over 8 on either side of this function. Lastly, let's graph y equals negative 5 tan of pi over 3x. So since there's no phase shifts or vertical shifts, as soon as we know a, which a is 5, I know that this is going to go up to 5 and down to negative 5. Because I didn't shift it left or right, I know in 2 increments this way I'm going to have a vertical asymptote, and same 2 over here. Now I can find the period by taking pi and dividing it by b, by pi over 3. This gives me a period of 3. So the distance from here to here is 3. So this distance is half of that, which is 3 over 2, and negative 3 over 2. Then the distance from here to here is half of that distance, so this must be 3/4 and negative 3/4. And I could have found those increments by just taking the period over 4, which would be 3 over 4. All right, finally, because this is negative 5, this will not increase, it will decrease, and it's just been reflected over the x-axis. All right, and so if I wanted to graph another period, I just continue adding in increments of 3 over 4. All right, and that's how we graph tan. Goodbye.